Okay, this video is for Megan. Megan, I'm sorry you were having troubles with these. I wanted to make a video to kind of walk you through the two different questions you have. So this answers both of those emails you sent me on the polynomials quiz, as well as the graphing polynomials function. Now, polynomials can be a little tricky and even at times, they can be daunting, like really hard to get your thoughts around because there's a lot of numbers and a lot of variables that go with it. But I wanted to go through and explain once again what polynomials are and just kind of the characteristics of them. So I wanted to give you this little lesson here and see if this helps answers both questions. The first one I'm talking about is going to be the quiz, the characteristics of the polynomials quiz. A lot of those questions, it says like which of the following is a polynomial function, or which of the following is a function with 3 terms and a lead coefficient of 4, and so on. What I want to do is I want to say, okay, let's first find out what a polynomial is. Okay, up until this point, you've dealt with probably mostly linear and quadratic functions. Okay, now we're getting into some much more complicated. And I wanted to show you this. A polynomial is usually in that format. Okay, and what that means is, there's a lot of letters and numbers and whatever, but they're usually written in order from least to greatest. So for example, I would say, okay, that's a coefficient on front of a variable with an exponent. So that could be like 4x to the third plus. Now we see that we're going to have a variable, and it doesn't have to be any, it can be like 2x, but we go down 1 in each exponent. So for example, 2x squared plus 3x plus 7. Okay, that's a polynomial. It's not inside a square root sign. It's not going to be found in a fraction usually. You're just going to find, for the case of this class and this lesson, this class, you're going to find a polynomial looks just like that. Okay, it starts with an exponent and works its way down. Okay, now a polynomial just means multiple nomials. Now what's a nomial? Well, it's a part, so it has more than one part, or has many parts here. Okay, each coefficient is just a number right there. Okay, and you always want to put the polynomial in order from biggest to smallest. Okay, the exponents from biggest to smallest. So see how I have a 3 here? Well, over here I have a 2, and then a 1, and then this would be a 0. So they're in order from greatest to least. Well, this 3 right here, that's my degree. Okay, so that polynomial that I just wrote right here has a degree of 3. Now, is it always going to be a degree 3? Well, of course not. That's going to change regularly. Okay, and let me give you a couple examples here. If I had this polynomial, let's just say 2x to the 7th minus 3x plus 0. Okay, again, is that a polynomial? Yes, it's got coefficients, it's got variables, and it's got exponents, and it's more than just 2. And so we see we have a polynomial here. What is the degree of this polynomial? This degree is 7, so it's a 7th degree polynomial. Now, what does that tell us? What does that mean? What do we learn from it? What's the point of it? Well, the degree tells us a whole bunch. Okay, and I'm going to come back to that example in just a second. But a degree tells us kind of the overall what the shape's going to look like. Okay, so this is a third degree polynomial. Okay, so I'm just going to write third right here, and this is a fourth degree. Okay, so we have a third and a fourth degree. Well, what does that tell us? If we count -1, we have a 2, right? -1, we have a 3. Sorry, I'll fit that in there. There we go. So if we have a third degree, that tells us how many extrema we have. And what is an extrema? Well, it's right here. So there's 1, 2 extremes. Okay, and this is a fourth degree, so it's going to have 3 extremes. 1, 2, 3. Okay, now where those are, well, that varies. But right now we're just dealing with the basics. Okay, so we know we have 2 extremes for that polynomial. It could be wide, it can be narrow. It doesn't exactly have to be exactly what what it's pictured here. This is just to help you understand it. Okay, now back to my example here. If I have this example, I know that's a degree 7, so it's going to have 6 parts where it changes direction. It's going to be like 1, 2, 3, 4, 5, 6, something like that. And obviously I don't know what the graph looks like, but I'm just saying 1, 2, 3, 4, 5, 6. Okay, and I'm not talking about whether it's starting up or down. I'm just showing you the different changes of directions there. The other part I wanted to show you is this one right here, that 2. Okay, when you put the polynomial in order from the highest exponent down, you will get what's called a leading coefficient. Okay, the leading coefficient comes in handy later on, and we'll get to that in just a second. Okay, so let me throw in a couple examples here. Okay, this first one, what is the degree? Well, it's a third degree polynomial because of that 3. What is the leading coefficient? 10. Okay, leading means first, and the degree is whatever that looks like. Okay, now if we look over here, what is the degree? The degree is 4, and the leading coefficient is 2. Okay, now I want to also introduce a couple other points right now, okay, to help you kind of visualize what's happening, because with polynomials, you want to know which direction they're heading. Okay, so we want to say, okay, does it increase, does it decrease? What is going on with all of these? Okay, why do I need to learn these different polynomials? Let me get this chart. I made a chart here. I'm sorry, I've got papers everywhere, but bear with me for just a second here. Polynomials, when you graph them, and this kind of goes in hand with your other, with what we were talking about at the other one, or excuse me, for the other question. When you graph them, you got to know whether it's going up or down. Okay, graphing a polynomial usually takes a lot of work, mostly calculators and stuff to be exactly accurate, but you can guess about what's going on. Okay, so we're going to look at this one, for example. Okay, now here we have examples of polynomials graphed. Zoom out just a little bit more. In this example, we see 2 different things. Okay, now this one is an even degree polynomial. Okay, so that means that if it's even degree, like if we have 2x to the 4th or whatever, that one right there plus blah, 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 blah. Doesn't matter. That degree right there means it's a fourth degree, so it's even degree. When it's an even degree, you'll notice that both ends end at the same side. So in this case, that one points up, and then it comes down and it points up again. Over here, it starts pointing up, and then it goes through its little things, but it still ends pointing up. Okay, so even degree, both ends of the graph will point in the same direction. Okay, now here it's a positive leading coefficient. So like my example up here, a 2, that's a positive leading coefficient. So that means whatever that graph is going to do, it's going to point up. It's going to point that way. Okay. Now if I had a negative leading coefficient, so if I said instead of 2, let's say I change that to a negative 2, negative 2x, well then that changes it. Now it's got to point down. So a negative lead coefficient, both sides point down, and a positive, both sides point up. Now let's just see if we can find out what the leading or what the degree of each one of these graphs are, just because we're looking at them. Remember, to find the degree, find the degree from a graph, you say, okay, this has one change of direction. Okay, so that means, remember how we found it? We did like -1, so a fourth degree would have 3 changes of directions. Well, to go the other way around, to go from the graph to the number of the degree, we just add 1. So this is going to be a squared. Okay, it's going to be a quadratic formula. So I can say that that is a second degree polynomial. Okay, so let's look at this next one right here. How many times does it change direction? Changes right here, and right here. So that's 1, 2, 3. It changes direction 3 times. So if I take 3 plus 1, I can see, hey, that's going to be a fourth degree polynomial. Okay, now let's look here. This is a negative leading coefficient. See, it opens down, so I know that first number is going to be a negative, and I see it only has 1 change of direction, so it's going to also be a second degree. And here we have 1, 2, 3, so that's also going to be a fourth degree. And both sides are pointing down, so that tells me it's negative. Okay. Now if I go to this graph right here and just do a couple quick examples with that, I say, okay, let's say I have this. I have, it goes like this, 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 this. Okay. And obviously the lines would have to be straight because it would have to be a function. But let's just say, for the fun of it, that I drew it right. Okay. We see that both sides are pointing up. Okay, with both sides pointing up, I know that it is an even degree. And I also know that it is a positive coefficient. Okay, even degree, positive coefficient. Well, what's the degree? It's 1, 2, 3, 4, 5. So we have 5, and then add 1 is 6. So this is going to be a 6th degree polynomial. So it'll look something like this, and it'll have to have a positive coefficient. So it'd be something, some number. I'm just making that up, but 3x to the 6th, and then so on. Okay, so I know that first letter is going to be, first variable and exponent is going to be x to the 6th. So I can look for that on the multiple question tests or, whatever comes up. Okay? So that's how knowing the leading coefficient and the degree become helpful. Okay? Now, what if it's an odd degree? Well, they're going to look something like that. Okay? An odd degree looks like that. We have one opening one direction and the other one opening on the other direction. So one opens down, one opens up, or one opens up and one opens down. Okay? Well, how do we know which one's which? Okay? Well, if we have a positive leading coefficient, what I do to think about it is think, okay, positive, it's getting bigger, it's going up, it's a positive slope. Okay, same thing here. It starts down here, ends up here somewhere, so it's got a positive slope. Okay? Now, if it's got a negative coefficient, the way I look at it is it's got a negative slope. It's going to start here and then down here somewhere. Okay? So it's going to go down that way. And same thing here. It'll start up here somewhere, go down that way. Negative coefficient, negative slope, overall slope. And I say slope, I mean you can see the slope changes, but I hope you understand what I'm talking about. Okay, now what's the coefficient of this one? Well, I only see really one direction. Okay, but does it have one? No, it kind of levels out. The way that graph, if you zoomed it in, would look like it'd be going up, come down just a tiny bit, and then keep going up like that. Okay, so you have 1, 2. So that would be a third degree. Okay, 1, 2. That would also be a third degree. Okay, right here, 1, 2. So that would be a third degree. And by third degree, I'm just simply stating that if I have 4x to the third plus 2x squared plus x plus 0, all I'm saying is this number right here has to have a 3 right there. Okay, that exponent has to be a 3. That's what I mean when I say a third degree. Okay, so here it changes there once, twice, 3, 4. So I would say that's a fifth degree. Okay, just by glancing at it. Okay, I know this is a lot to digest. Okay, now if we look through your quiz, you missed number 1. It said which of the following is a polynomial function, and you put that the following polynomial function. Let's see if I can find a way to do this so you can see what I'm talking about. I don't want to give you the correct answer in case your mentor lets you retake the test. Okay. Okay, so you see right there it says, okay, which of the following is a polynomial function? And it gave you a list. I don't have the list in front of me. But the reason why this is why this isn't right is because you've got the square root there. Okay, it cannot have a square root symbol. It's just got to be just, the x and the coefficients and the variables. That's it. Okay, so hopefully that helps with that one. The next one says which of the following polynomial has a is a function with 3 terms. Okay. Let's see. Give me just a second here. All right. I'll do this after. So we'll zoom in. Which of the following polynomial is a function with 3 terms and a lead coefficient equal to 0? Okay, 3 terms, meaning it has 3 pieces. Okay, so you got that part right. 1, 2, 3. But right here, you put it as 4 to the x, is what it looks like to me. And it can't be that, okay? It has to have a number up there. So like 4 squared minus 3x plus 4, something like that, okay? But you can't have just 4 to the x power. It has to be a number, okay? Let's see, next one you got right. And that next one, which of the following is not a quadratic polynomial? You got that one right. And all the way down at the bottom is the function f of x equals 2 over x to the third, even, odd, or neither. Okay, well, sometimes you're going to see it in a fraction. What's the highest degree right there? That's a 3. So that tells us that it is an odd degree polynomial. Okay. The whole next page, you only missed a couple. Which of the following functions can be described as increasing then decreasing? Okay. Now let's think about it. Increasing, so it starts down here. Increasing, and then it's going to decrease down here. Let's zoom out. Okay, increasing then decreasing. Now it could look like that. It could have a whole bunch of stuff in between, but think about it. Both sides are pointing down because it's increasing, then it's decreasing. Okay, so if both sides are pointing the same direction, then we see that it has to be an even degree. Okay, and it has to be negative coefficient. Okay, it has to be negative coefficient and an even degree. So that means the first exponent has to be an even number. And whatever coefficient that exponent has to have a negative number. Okay, so if we look at your answer, we see, okay, you put a 3, but there's no negative there, and you had a 3 up here, and that's an odd, okay? It would need to have a negative 3x and then some kind of even coefficient like a 4 or a 2 or something like that, and then plus blah, 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 whatever, okay? So it's got to be a negative with an even, okay? Now, let's look at this. Describe the end behavior of that polynomial. Okay, once again, let's look at it. Has a negative coefficient, so it's going to start at the bottom if that's even. Okay, so we see it's got a negative coefficient and it's even. Okay, well, with a negative coefficient and even, let's look at this. And I'm going to write the equation right here. So if we have negative 4x squared plus 5x minus 2, okay, it's an even degree, so I know both sides are going to end down here, okay, and I know that because it's negative and even, okay. So because of those 2 bits of information right there, I can tell where it's going to start and end. Now, remember what I was showing you. If we have 2, well, we take 1 away, and that leaves us with 1. That's the change of directions. So it's going to start here, go up, change directions only once, and then go back down. Now, I don't know where this is. but it doesn't need us to say. Okay? Now the question is, okay, what are we doing? What's happening? Okay? The left behavior, what's going on over here to the left side, right here? On the left side, what it is it's as x approaches that direction. Well, what's that way? Well, that's -1, -2, -5, -10. So as it gets closer to -infinity, okay, f of x is going to get closer to -infinity. See how it's just going down negative? So the farther negative it goes, the farther negative y goes. Okay? Now let's look at this direction, the right. As it increases 5, 10, 15, and infinity, as it goes off to infinity, well, what happens here? It's going down -5, -10, -15, all the way down to -infinity. Okay? So if it goes all the way down to -infinity, then we can say as x approaches infinity, f of x approaches -infinity. Okay? So that kind of, it gets confusing, but that's what happened on your quiz. Those are all the ones you missed on your quiz. You can go through and hopefully that makes a little more sense. Now, with that in mind, you also asked about graphing polynomials, okay? And that's what I want to get to right now. So if we look at number 1 on the homework, I've printed that out somewhere. There we go. We say, okay, the equation we're looking for is 2x cubed plus 1. So 2x cubed plus 1. Okay, now with that in mind, can we decide what direction it's going to be going? Okay, well, I know it's going to have 2 changes of direction because it's got the 3 right there. So I know that 3 means it's going to change direction twice. Okay, it's got a positive coefficient, but it's an odd degree. Okay, positive but odd. That means odd degree, it starts one corner and goes to the other. Okay, starts at one corner and goes to the other. So which one does it start at? Does it start up here to the left and go down, or down here and then go up? Well, remember, this is an even coefficient, so think about it, it's always going up. Okay, so I think it's going to go down here and it's going to end up here somewhere. Okay, and the reason why I think that is because it's positive, so it's like it's going to have a positive slope. Okay, positive leading coefficient means it's a positive slope. Okay, well now, what do we have to do to figure out where it graphs? All right, well, the first step we want to know is where it crosses the y-axis. When it crosses the y-axis, that x has to be 0. Okay, so 0, when that x is 0, what is the rest of it? If we change x to 0, we have 2 times 0 is 0, and 0 cubed is 0, so that leaves us with positive 1. So I know it's going to cross right here. I know when it's 0, when x is 0, f of x, or y, same thing, is 1. Okay? Well, now let's just go both directions here for just a second here. Let's just say I want to see where it goes when it goes -1. Okay? Well, what's -1 cubed? -1 times -1 is 1. 1 times a -1 is -1. Okay? So now we've got -1 times 2 is -2. -2 plus 1 is -1. So I know that's going to go right there. Okay? And we can always check the work on a calculator. Okay, so like 2 times -1 raised to the 3rd power plus 1. And we see -1 is correct. Okay, well, let's keep going. Now I want to see what happens when it's 1. 1 cubed is 1. 1 times 2 is 2. Plus 1 is 2. Okay, so I know that's going to go right there. Now what happens when this is 2? 2 times 2 is 4. 4 times 2 is 8. So 2 cubed is 8. 8 times 2 is 16. 16 plus 1 is 17. So that's way up here off the chart somewhere. Okay, just even beyond where I put that mark. Okay, let's try -2. -2 cubed is, and I'm just going to make sure I do it right, is -8. Got to remember the negative sign. -8 times 2 is -16. And then plus 1 is -15. So that's right here. Okay, so I see this graph goes up, levels out right here. Remember, it changes direction once, twice, and then it goes back up again. Okay, now the actual graph looks a little neater than that, but I don't care so much. Okay, it doesn't need to be perfect, but if you look at that, that's the actual graph of that function. Okay, you see how it comes up nice and neat, levels out at the plus 1, and then keeps going. Okay, what I need to know is where it crosses the y-axis and what it looks like. Okay, and where it crosses the x-axis. Those are the things I'm interested in. Okay, so let's try number 2. Number 2 says negative x minus 2 squared. Okay, well, let's simplify that out. You know, let's figure out what's going on. We've got to actually square that. Okay, so we're gonna just use this on some scratch paper here, and we're gonna say, okay, if I have that, I have, okay, we square those, so x minus 2 times x minus 2, and that goes out, and you get x squared minus 2x minus 2x plus 4, and that simplifies down to x squared minus 4x plus 4. Okay, but now let's not forget we have that negative that we got to put on all of it. So we've got a negative x squared plus 4x minus 4. Okay, because remember, we just, we're timesing that whole thing by -1. So we change the sign of each one of them. Okay, so our new equation that we're trying to graph, it goes from that, and then it turns into negative x squared plus 4x minus 4. Okay, so what do we know about this graph? Okay, it's an even degree, which means both sides are going to open on, or both ends are going, it's going to end in both directions. So it's either going to look like, come down here and here. Okay, if it's negative, or if it's positive, it's going to end up here and here. Positive is happy, so you make a happy smiley face. Negative is frowny. Okay, so that's negative, that's positive. Okay, and it could have more terms in it. We haven't really gone into that. We're just looking for negative and positive. And we see that it is an even degree. And not only an even degree, but it's a 2. So that means there's only one change of direction. So it's going to look like a U, but then it's got a negative coefficient. It's got a negative coefficient, so we know it's going to be upside down U, like that. Okay, so let's make our t-chart, and let's find out where it crosses the y. So we want to say when x is 0, what is y? Because that's when it's going to cross right here somewhere. Okay, we think down here because it's going to open down, but let's just see. Maybe it's way up high. If we plug that in, 0, 0, and then minus 4, so we see it crosses at -4. Okay, now if we go say, all right, let's move forward a little bit. Okay, let's go 1. When it's 1, we have, and we can plug it into the calculator here. We can say, all right, we have, let's type it in, negative x, which is 1, and we got to square that. Okay, plus 4 times x minus 4, and we see we're at -1. Okay, so when it's at -1, we're at -1. Or excuse me, when it's +1, -1. So that's -4, that's -1. What happens when we get to 2? Okay, let's just plug in 2 and see what happens. So we've got -2 squared -2 squared, and then we're going to say, hey, that's also -2 minus 4. Oh, excuse me, I'm doing -2. Let's try that again, but with a +2 like I originally wanted. 2 squared, 2 squared, or plus 4 times 2, minus 4. Okay, so all I'm doing is I'm plugging in a 2 for each place I see x. Okay, and I hit enter, and I see it's 0. Okay, so when I go out to 2, it stops right there. Now let's see what happens when it's 3. Okay, and we're going to go back and say, okay, 3, enter, -1. And I'll bet this one's going to equal -4. So if we plug in a 4, so now we're going to do a +4. We go through and change all those x's, and we see -4. Okay, so what are we noticing? We see the shape, don't we? We see where the U happens. It goes up like this, curves, and comes back down. Okay. Now the things I'm looking for the y-intercept and the x-intercept mostly. So when you graph this, look for that. Now we're done with that one and we can move on. Okay, let's do number 3. And then, we'll just talk about the rest without doing every single one of them. So I don't want to do your homework for you. That's not fair to you, as much as I'm sure you'd love it. Okay, number 3. 1/2 x to the 5th. All right. Now that's our equation. F of x equals 1/2 x to the 5th. Now what can we tell from this? It's an odd degree. So that means it's either going to open, or it's going to go from one corner to the other that way, or it's going to go from this down to here. Okay, we don't know just yet. Is it negative or positive? That's a positive. I don't know why that little dot's right there. Oh, equal. I did equal. Okay, so it's a positive 1/2. So that means it's going to have a positive slope. That's just my take on it. So I know it's going to start down here and end up here. Okay, where is it going to level out? well, it's, how many times is it going to change direction? If we look at it, it's going to change 4 times, but we're not going to worry about that so much. Is where does it cross the y-axis? When x is 0, what is everything else? It's 0. Okay, so I know it's starting down here and ending up here, but it levels out right here. Okay, now let's put in a 1. If we cube 1, we get 1. Okay, or excuse me, 5. 1 times 1 times 1 times 1 is 5, it's 5 times. So we get 1. 1 times 1/2 is 1/2. Okay, and that tells us, let's see, what number are we on? We're on number 3. Okay. If we plug in 1, sorry, I just confused myself, but if we plug in 1, 1 times 1 times 1 times 1 times 1, 5 times, we get 1. 1 times 1/2. And so when it's 1, it's 1/2. So it's going to go up like that. Okay. If we plug in 2, 2 to the 5th power is 32. So that's way off the chart anyway. So it's going to go up like that. Okay. Now if we plug in -1, okay, -1 to the 5th power is -1. -1 times 1/2 is -1/2. Okay, and if we plug in -2, -2 to the 5th power is -32. So we see that goes straight down like that. Okay, now it's going to do other kind of manipulations. We know that the whole thing's going to have 4 changes of direction, but our graph isn't big enough to match all of those, or small enough. I'm not sure. If you get right in there really small, right in here, it may look something like this. Okay, I don't know, but we're not going to worry about it. The general shape of that graph looks like this. Okay, and that's all you need to draw. Okay, just the general shape of the graph. And I'll actually do one more for you. Okay, we'll do, as I look, number 5, you just simply need to simplify it out. Okay, so number 5, you just need to distribute the 2 to the x and the 5 after you cube it. So you got to do x plus 5 times x plus 5 times x plus 5. Okay, remember your order of operations. The exponent has to come first before the multiplication. Please excuse my dear Aunt Sally. I hope, don't know if you remember that, but now let's look at x times 5. We got x squared. Oh, excuse me, gotta keep going with that one. Plus 5x plus 5x plus 25. So that leaves us with, let's do it so we can see it, x squared plus 10x plus 25. And all of that is going to be times x plus 5 again. Okay, so again, I'd put that one up front here. It's much, much easier. Okay, so let's start. X, you get x to the cubed plus 10x squared plus 25x. So we're just multiplying x throughout all of them. Now let's multiply 5 throughout all of them. You get 5x squared. Now I'm lining it up here because the squared, so I want to have the squareds lined up. So then 5 times 10x is 50x, and then 5 times 25 is 125. And then if we go through and just simplify that out, we get x cubed plus 15x squared plus 75x plus 125. Okay, so that is x squared plus 5 cubed is that. Then we got to take that whole thing and multiply it by 2. Okay, and that gives us what? 2x cubed plus 30x squared plus 150x plus 250. Okay, all kinds of fun. Those are all kinds of big numbers. Okay, and then all of that is going to have a minus 1. Minus 1. And we can combine those down to be a plus 249. Okay, so then you just go through like I've been showing you, do your t-chart, x, y, find out when x is 0, and then go from there. So when x is 0, it's going to look kind of like 0, 0, 0 plus 249. So when x is 0, it is way up at 249. Okay, that doesn't help us much. Okay, which way does it need to go? Well, let's change it to 1. If we change that to 1, that's 2 plus 30 plus 150 plus 249. That's going even further away. Let's change it to a negative. And we say, okay, with the negative, we go I'm just going to plug that one into the calculator because that one's too hard for me to do by hand. So if we say, okay, 2 times negative 1 cubed plus 30 times negative 1 squared plus 150 times, let's just put that in parentheses, negative 1 and plus 249, and we get 127. So you see it's starting to come down a little bit. Okay, so let's plug all that in and just do change that from negative 1. We're going to say, hey, instead of negative 1, we want you to try it with negative 2. Okay, and you can go through and do each one of these by hand and just figure out negative 2 squared, negative 2 cubed, and so on. And that gets down to 53. Now we're starting to get possibly within a graph here somewhere. Negative 3, negative 3, negative 3. So when it's negative 3, it's 15. And let's go through, change them all to negative 4 and see what happens when we have negative 4, negative 4, and negative 4. You see it's 1. And when we do negative 5, we're at negative 1. So we can see exactly where it crosses the x. We can see kind of how fast it comes down. Now we look at I've been writing those over there and you haven't been able to see them. I'm sorry about that. But we can see where it's coming down. Negative 4, 1, negative 5, negative 1, and so on. So I'm keeping track of that. And we can say, hey, it's an even coefficient with an odd degree. Okay? Well, if it's an odd degree, that means that it starts in one corner and ends in another, goes diagonal. Well, if it goes diagonal, okay, if it goes diagonal, then it either has to start up here and go down, or it starts down here and goes up. And we see it's a positive coefficient, so it's going to go up, okay? And that makes sense with kind of, what we're doing. Up here at 0, it's way off the chart. -1, it's getting closer, so it's coming down, and then it kind of levels out and then keeps going down, okay? So that's how you do that one. And number 4, same thing, only we don't need the 9 in front. We need it to be -x4 plus 9. Okay, we're just going to move the 9 to the back. And then we have our coefficient is a -1. And we have our degree. And we plug it into a t-chart and say, okay, when x is 0, y is 9. Because 0 times all that is 0, plus 9 is 9. Then you plug in a 1, and then a 2, and then a -1, -2, whatever. And then just keep track as you're going, okay? And that's how you graph those. I don't care so much about the exact nature of the graph, every single little curve and everything. That's not what bothers me. What I want you to look after is the general shape of the graph. Where is it starting? Where is it ending? I don't even care about the number of bumps, number of direction changes. Again, just where does it start, where does it end, and kind of what is the general shape. So I hope this helps. If it doesn't, let me know, and we'll get together in a class chat session, or you can always go online to the online help. There's a link right in each class. And so yeah, send me an email, let me know if this works or helps.